All right. We are doing another type of word problem for systems of equations. Remember, that's where we have two lines, and we got to find the point of intersection where they're the same. So the way this one's going to work is speed equals distance time. This is where you're dealing with speed questions. Usually there's a current as well, is what they're called, like someone's going upstream or downstream in a boat. The first thing I want to tell you is how to calculate speed. When I think of speed, I think of driving on the highway. You go like 50 kilometers per hour. That's how you measure speed, which is really what you're saying is distance divided by time. That's speed. So the formula you need to remember is D equals, speed equals distance over time, okay? And again, if you don't remember that, just think of the 50 kilometers per hour as your speed thing. With that in mind, let's read the question and try and figure this out. Zian was able to make a downstream trip of 36 miles in 2 hours, okay? Returning upstream, he took 3 hours to make the trip. So we got to write this using these equations. What's going to happen is there's going to be like trip 1 equation and trip 2. We want to know how fast can the boat travel in still water and what was the rate of the river's current. So this is kind of weird. The idea is like if you're on a river, rivers flow. They have like movement, speed. If a boat goes in the water and it goes the same direction as the boat, it gets a speed boost, which means you would add the boat speed with the water speed. If you're in that same water and it's flowing to the east, whatever, but you're in a boat and you're trying to go the other direction, you're gonna get slowed down. The reason you're gonna get slowed down is because like the water is pushing into your face. So you're gonna get the boat speed minus the water speed. That's some level physics right there. That part you just have to remember and understand when you're doing these kind of current questions. So let's try to write an equation that shows like what's going on, okay? So we're gonna write our formula, speed equals distance over time for trip 1. For trip 1, it said he'd made, it was 36 miles in 2 hours. So let's put the numbers in. 36 miles is gonna be distance, 36. The time is going to be 2 hours. Cool. Now I got to put speed in. The problem with the speed is when he's going downstream. We got to realize what that means. Downstream is this one, where you get the boost. The water's pushing you. Okay? So I'm going to do the boat speed plus the water speed. Because it's the boost, it gets added. We should define our variables. Boat speed and water speed. Okay. Now on the way back, it was still 36 miles. It didn't say this, but it said it's the same trip, right? But instead this time it took 3 hours. So I'm going to write for my time 3 hours. Now again, we're going to have the boat speed and the water speed. But on this trip, you were returning upstream, which is this one, the one where you're going against the current, so you get a negative. I'm going to write B minus W. So now when you look at it, we have our two equations. They're kind of ugly equations and can be simplified a bit, but they're set up properly. So let's try to do the second one. We'll flip down a bit and get some more space. Okay. Boat traveled 36 miles up a river in 3 hours. Oh my gosh, that's the exact same question. Oh well, okay. We'll just change the numbers. So we'll make them go like 54 miles. And we'll make him, it'll take him like 5 hours, whatever. But then when he returns downstream, it only took him 4 hours. Cool. So we're gonna write our two equations. We're gonna have trip 1 and trip 2. So trip 1 was upstream. When we're upstream, we got the resistance. So boat minus the water speed. It was 54 miles over 5 hours. The second trip, again, we're gonna do our distance over time. I know it was 4 hours and the trip was the same distance. Some questions will give you different numbers, but that's the idea. And then we have the boat plus the water speed because it was downstream, so it got the boost. And now again, we have our two equations set up so we can solve the rest of it. And that's it. That's how you set these questions up.